Dad, what's the future gonna look like?
I'm gonna let you all down fast and easy. I won't be unveiling any new aircraft, rockets, or spaceships today. I'm Carrie, one of the co-founders and chief operating officer at Pacific Fusion. And I know that you all have a vested interest in what we are building: an abundant, affordable, clean energy future. In my former role as an investor, I'll admit that when it came to fusion, a technology that's been the future for decades, I was skeptical. So today, I'll take you on the journey that I went on, from skeptical to convinced that fusion will actually work soon. First, I'll cover what fusion actually is and why people have been so excited about it for half a century. Second, recent breakthroughs that transform the field. And third, Pacific Fusion's resulting roadmap to actually delivering fusion energy. First, let's talk about fusion. Fusion is what powers the sun and our stars, and it is conceptually simple. You squish light atoms together hard enough and for long enough that they fuse, resulting in heavier atoms and converting some matter directly into energy. The energy density of fusion is enormous, and to put this in perspective, a fusion power plant would require less than 1/100th of the land area and 1/10 of the material of a wind farm with the same nameplate capacity, and it would work whether or not the wind is blowing. It's the ultimate endgame, with no dependence on intermittent resources, no long-lived nuclear waste, no fissile material, and no carbon emissions. I don't think I have to convince anybody here that energy is important. As Eric Toon loves to say, energy is prosperity. And today, energy is also intelligence, fueling the age of AI. The more interesting question is what changes when we actually make fusion energy work. With that in mind, I'll go through a couple quick pie-in-the-sky visions for what this could look like, starting with a baseline. Here, fusion power is available but expensive. At this stage, fusion is about security. Secure, clean baseload power for critical infrastructure, and fusion for critical defense purposes. Now on to the bigger pie. Here, fusion is widely available and affordable enough to power everything that we need, including next-generation transportation. Energy is finally manufactured rather than extracted, providing a path to energy security for countries around the world. But of course, the ultimate goal is the giant pie. And here, the sky is no longer the limit. Think fusion-powered space travel, chemical fuel production on the moon, and so much more. The real question is not about the potential. It's about why none of these realities have materialized. Since the 1950s, the running joke has been that fusion is the energy of the future and always will be. That is no longer the case. To put this in perspective, let's actually look at the last few decades of progress in fusion. The y-axis here represents the most common measure of fusion performance, and the horizontal line at the top, the threshold at which you get more energy out than went into the fuel. There are two leading ways to do fusion. The first is steady-state fusion, usually tokamaks, shown here. The record result today is from 1995, a factor of a few from the scientific finish line. The second is inertial fusion, represented by the second line. It entered the field more recently, but has progressed so rapidly that in 2022, it crossed the scientific finish line. This was the first of 3 breakthroughs that transformed the field: controlled ignition at the National Ignition Facility. The second breakthrough is also scientific. Researchers at Sandia National Laboratories in New Mexico demonstrated the second best fusion performance ever using efficient electric pulsars instead of lasers. The third breakthrough is an engineering breakthrough. Our CTO, Keith, demonstrated technology that makes electric pulsars more than twice as efficient and power dense as the current state-of-the-art, and most importantly, mass-manufacturable and modular. Taken together, this means that we know the conditions for ignition, and we can build an efficient, modular, mass-manufacturable machine to reach them, meaning that we have a major engineering project on our hands to make fusion real, but not a scientific moonshot. When we founded Pacific Fusion in 2023, we raised more than $900 million of private capital at founding because we're building a first-of-a-kind industrial project with a viable path to fusion energy. Our investors include some of the very best, including today's hosts, partners, and Truesdale. Importantly, the capital is tranched against milestones corresponding to a methodical de-risking path. And to deliver those milestones, we first built an incredible team. Our team is now about 130, including many of the folks most responsible for the breakthroughs that I mentioned. And importantly, they're pragmatists, only interested in building things that will work. Let's talk about the tech. We're building a machine with 3 subsystems: a pulsar, which creates a big electric current, a chamber, and a fusion target. In the pulsar, capacitor banks store electrical energy, and they discharge that electrical energy to make a big electric current. That electric current is run across a little can holding fusion fuel, the target, and squishes that fusion fuel hard enough to cause fusion. The pulsar itself is highly modular, consisting of 156 identical modules. To put this power density in perspective, each module produces about 2 terawatts of peak power over about 100 nanoseconds, but that's about 4 times more power than the average power of the entire United States electrical grid in the footprint of a shipping container made from oil, plastic, metal, and water. By next year, we'll have demonstrated that one module works as expected, a key milestone on our journey to commercializing fusion energy. So far, we've executed against all milestones ahead of schedule, proving that the building blocks of these systems work. And once we've demonstrated that one module works, building the next 155 is a matter of execution. We're building with the right people, we're building on established science, and we're building fast. I hope we can all agree that it's no longer a question of if fusion will work, but when it will work, and who will build that future. Because American private fusion companies are not the only ones building. China is right on our tails, as you can see, for example, from this 150-acre inertial fusion facility built by China's weapons laboratories in just the last 2 years. This is a race we have to win. And for the first time, we have the scientific and engineering foundation to do it. And the stakes are high, because inventing and building this technology will shape geopolitics for a century to come. I look around this room. Many of you are working tirelessly to build the best aircraft, rockets, and spaceships. And like fusion, these innovations once lived only in science fiction. Fusion energy has the power to literally launch us to worlds beyond our imagination. And where abundant and affordable energy meets pragmatic execution, there are no limits to what we can build together. Thank you.
The future is gonna be awesome.